Okay, so here's your You Missed It for live session number 2. So this was just our information. Down here you can see our agenda for today. So the first thing we did was we asked each student to classify the above graphs, and how do you know which ones they are? So what you need to do is you need to go ahead and pause this right now and go ahead and try and do that. When you think you have your answers, unpause. So this first one we decided was a quadratic. And we know it is a quadratic because there is a parabolic shape, which means that there was a vertex, you have the U shape, and then that there's symmetry down it. That's how we knew this one was a quadratic. As we scroll over, we decided that this one was a rational. And we knew that it was a rational because it looked like it had multiple graphs. And that look is created by some asymptotes. So we have an asymptote here, we have an asymptote here, and we actually have horizontal asymptotes going this way. This third one here is going to be a polynomial. And we know it's a polynomial because it's all connected. There are multiple x-intercepts and multiple max and min. And so a reminder, we're going to talk more about that today. Max and min are these high and low points. So these are all things that allowed us to know that it was a polynomial. The last one we looked at here was an exponential. We all decided it was an exponential, that even though this one is curving down instead of up, there is still this flat portion and then this steep portion. And that really, really flat with a steep curve is the key characteristic of an exponential graph. And so just a reminder, this was the review of the lesson that we did on Monday or Tuesday, the very first live session of knowing the different types of graphs. We moved into getting started. So this was a good review of your verbal understandings activity you did, which is being able to understand the different parts of a graph. It was also a good reminder of function notation. Once again, what you need to do is you need to go ahead and pause, do this activity in your notes, and then once you're done with that, come back in for me explaining it. One of the things that we talked about is this notation down here is known as function notation. And a reminder that function notation is f of x equals y. So whatever is in the parentheses is known as the x, and whatever is on the other side of the equal sign is the y. So we can use that to help us solve. Over here, then, we can say this was an x of 0. And it was asking for the y, so that's probably approximately 2.3 or 2.25. The next one was a d of 12, so we can come up and we can figure out the d of 12. We said that that was approximately 0.75 or approximately 0.9. These two down here, we're actually finding what's inside the parentheses. It's labeling it as m because it's minutes, but we know that that is the x value for this. So we're going to go ahead and we're going to find that y value. Well, where the y value is 1, is right there, slightly less than 12. So we said m was equal to 11. Same thing here. We want to know when the y is 0. Well, that's right here. M is equal to 20. The next thing we asked was just to kind of clarify this statement. What would that mean in your own words? So in the context of the problem, what does this point mean? Go ahead and try and come up with that on your own. And we said that this meant that it took Diego 20 minutes to make it home because he is 20 minutes away. That's how long it took, and the distance is now 0. So this was the next part of our activity. We're going to talk about how can we talk about graphs, how can we make sure that we are explaining graphs, that we're giving the correct characteristics, that we all know that what we are talking about. This was a fun activity, sad you guys missed it, where each student was able to create their own graph, and then they put them in the chat box and I got to try and draw some. So I'm just giving you an example of what I saw there. Let's use these characteristics. So this actually looks like a really good description. It says, okay, it's a parabola, so we know it's going to be that U-shape. There's a vertex at 0, 1, and it's going to reflect down. So I'm going to say, I think it looks like this. Not my best parabola. Let's try that side again. So when I drew it like this, I was like, yo, no. What he forgot to tell me was actually that the x-intercepts were right here. So you can see by just adding the extra information of where the x-intercepts were, we were able to get a better picture of the graph. Another example was a student who said it starts with a line. It goes straight, then goes back down. Same as first portion. Well, the example here then, I said, okay, let's say it starts with a line, any old line, so I'm going to go from here to here. Oops. Nope. And then it goes straight for a bit. And then it goes back down for the same amount. So that was the graph I gave, but they said, oh, I didn't explain how long and where it started. Theirs started at 0. Each box was only 2 long. And then, so theirs looks more like that. So you can see, even though I had a similar shape, it wasn't exactly the same. So being able to give as much information as possible, such as starting points, for how long it goes, things like that are going to be able to help us be able to get the correct graph to make sure that we're all talking about the same thing. So that's kind of the importance of today. This was the key needed information. A lot of this you've probably heard before, so we'll start with x-intercepts, and the other fancy word we use there is a 0, and this is simply where the graph crosses the x-axis. The next part then is y-intercept. This goes with it, which is where your graph crosses the y-axis. Then we get to some that are maybe slightly more difficult. Local max and local min. Local max, and this is what you just saw. We just say is what that's supposed to say there. We just say max and min most of the time. When I ask you to find a max, I'm talking about the local max. When I ask you to find a min, I'm talking about the local minimum. And so these are really your hilltops and valleys. We give their location. With an x value. So I'd say it has a maximum at x equals 2. And that's telling me that there's going to be some sort of hilltop at x equals 2. I said there's a minimum at x equals -3. That's telling me at x equals -3, there's going to be a valley. You can give the value. You could say that there is a maximum at x equals 2 with a value of 10. That's going to give me the specific point, but when we're giving location, we're going to talk about x value. End behavior, you guys have talked about in IM2, and so just a reminder, we're talking about what the ends are doing. And so just really, really quickly, for this one, a quick little parabola, we would say both ends are going up. So as x goes to the left-hand side, y goes up. As x goes to the right-hand side, y goes up. So both ends are going up. Versus a cubic, so something we're going to see a lot more, they're going in opposite directions. So the left-hand side, the y is going down. On the right-hand side, y is going up. And we're going to talk about more fancy notation there and how to explain that. But that's just what we mean by end behavior is really what are those arrows doing. The last one then is increasing and decreasing intervals. So a reminder that when we talk about a graph, we're always going from left to right. So when we're going from left to right, x is increasing. And that's just saying, it goes 0, 1, 2, 3, 4, etc. Our x's are just getting bigger. So when I say x is increasing, I really just mean going from left to right. And so an increasing interval is anywhere where x is increasing, y is also increasing. So as you look at it from left to right, it's getting bigger. And so what that might look like is this. That is a portion that as x was getting bigger, so from left to right, the graph was getting bigger. Decreasing then would be as x goes up, because once again we're saying from left to right, y is going down, it's getting less. And so another example would that be the other side of a parabola, it's coming down. So this portion is increasing. This portion is decreasing. And it's all about as you go from left to right, what is the graph doing? So think about you are a little ladybug, you've hopped on the graph over here, and are you climbing up the hill or are you climbing down the hill? So that's what we're talking about with increasing and decreasing intervals. As a reminder, your next thing that you're going to do after watching this live session or this live session recap is to watch the lecture video that Ms. Adana created, and it goes into all of these key features in a lot more detail. It gives you those nitty-gritties. This is just the overview. So here we wanted to talk about an actual context and see how can these features help us. And so this is talking about a bungee jumper. So bungee jumper jumps and the height is given as a function of time. So height is our y, function is time is our x, since the jump began. So the jump began over here at 0. And this represents the height in meters above the river. So when we bungee jump over a river. So what I ask students to do is to sketch this down in your notes. You should go ahead and do that as well. If you need to pause for a second, you can to get that sketched. And then we talked about what is happening. And so we were able to say that from this, we can tell that the bungee jumper is getting closer to the river. And then when they hit a low part, they're kind of bouncing back up. So we can really just follow this. They're coming down, they're hitting a low part, they're bouncing back up. And then each of the bounces after that is getting a little bit less. So this is their deepest dip. This is the closest they get to the river. And then they keep bouncing a little bit, but they get less and less each time. So now we want to look at those key features and we want to talk about what they mean. For each of these slides, when I get to it, you should pause, answer the question on your own. Once you think you've answered it, then come and see what my answer actually is. So let's start with the y-intercept. So the y-intercept was here. We said that looks to be about approximately 0.75. So we're able to locate it. And this is what this represented on the journey. And so that was the starting point. Or where the platform was. So wherever our bungee jumper was jumping from, this is that starting point. This is how high the platform was. Then we talked the x-intercept. Well, we looked here and we said it doesn't actually ever cross the x-intercept. And if this keeps kind of doing this on its way out, it's not going to get there. And so we don't have an x-intercept. But we asked about, well, what would it mean for this? Well, if we're 0 meters above the river, then if we actually had an x-intercept, it would represent hitting the river. I did have someone in one of my classes make the really good observation that, we don't have it right now. Say that at this point she unhooked herself. There might be a quick drop, and she would be in the river after that, and that's where our x-intercept would be. So making that observation that this is assuming she's still connected to the bungee cord. At some point, you're going to have to unhook yourself in order to get out. Whenever she jumped into the water, that is when we would have our x-intercept. So that was a good way to put things in context and kind of estimate what's going to happen in the future. All right, maxima and minima. So we're going to hit these in color. Let's start with our maxes. Once again, a reminder, you should have paused each time you get to a new slide. So, until you get them by the location, so I would say we have a max at, and I would say x equals, I'm going to estimate these as best as I can, looks to be approximately 9, maybe 18, and 27. So we would say those are the locations of all of our maxima. If you wanted to be more detailed, you could then give the value. So once again, the location is the x value. The value is the y. So this is where they are, and then we could say, you know, there is a maximum at 9 seconds, and it has a value of 42 meters. So that's how you could put that into context, into words. Minima, on the other hand, really similar, but they're going to be all these valleys. So I'm going to say that my min are at x equals, let's say 3, 13, 23, and 32. So those are just my estimations of these points. The next part is actually saying, what does this represent on the journey? And so what it represents on the journey is the part where they stop falling. So the minima is where they stop falling and they start rising again. So we know that our jumper is kind of bouncing. They got close to the river, and then the bungee cord itself is pulling them back up. So this is going to represent those low points, is where they stop falling and they start rising. Versus the maxima is that part where they stop rising and they start falling. So the cool thing here is, putting that in context, we actually kind of learn a new word. You will find out we will call max and mins turning points. And that's because it's the spot where it turns from increasing to decreasing. So when you switch from increasing to decreasing, or vice versa, that's when you're going to have a max or a min. So that switch from increasing to decreasing, that's that switch here. That's going to be a maximum, versus decreasing. You know, if I switch from decreasing to increasing, the switch was here, that was a minimum. So that's what we're talking about there. Which goes ahead and gets us started for this. The really cool thing is, since we know our max and our mins are our turning points, our increasing and our decreasing intervals are going to be between them. So I can actually go ahead and kind of mark those out again and say, hey, they're going to switch between these. So if we start with increasing, all of these are our increasing intervals, because as we go from left to right, they are getting higher. The y value is getting larger. And you can think about it, it makes sense that it's increasing because they're bouncing back up in these portions. Once again, we give our intervals with the x values. So we're saying, where is it increasing? So it's increasing from, let's try that again, 3 until 11. We put this really fancy U. It just goes in between our intervals to know that we're saying, hey, it's this one, and then again this one. So we take a break, and then it starts again at 13 and goes until, what did we say that was, 18? Starts again at 23 and goes again until 27. And those are all of our increasing intervals. So once again, I was giving you those x values. I was saying from here to here, from here to here, from here to here. But what about our decreasing intervals? Notice that's the rest of the graph. Oops, I forgot that increasing interval over here. You would include that. I just forgot it for now. We're not going to go back. But notice that the decreasing interval took the rest of the graph. So any x value that's not increasing is therefore decreasing. And so we can say, well, our decreasing starts at 0 and it goes until 3, you're going to notice that there's going to be some overlaps in numbers, because where it stops decreasing is where it starts increasing, and the other way around. So it starts decreasing again around 11, and it decreases until 13. It's going to start decreasing again around 18, and it decreases until 23. It's going to start decreasing again around 27 and decrease until, I think we said that was 33. So you can see all these portions. So this is what we're talking about with increasing and decreasing intervals. I do want to be very clear. Ms. Adonic gives a much better detailed account of this in your video that you're watching after this. So don't forget, you do have a lecture video named Key Features, which is a much more these are just the notes that go along with this activity that we're talking about. And we already talked about, what do they represent? They represent the falling portion versus the rising portion. This is a fun one that we didn't get to, so I would say if you want to pause and try it, go ahead and pause and try it. I will give you what I think my final answer is. That was loud. I think the bungee cord is 50 meters long, and that's in its unstretched. So the bungee cords, stretch out further. So that's what I think my answer is. You can try and come up with that. If you want to talk about it with me in office hours, if you want to, you can. And then this was the last part. This is a discussion post that I'm asking each student to do on their Schoology page. And so make sure this is kind of just a recap of the lesson. Here's the prompt. It says a student was asked to describe this graph. They said that it was increasing from 0 to 1, and then it decreased from 1 to 3.2. And they said it had a maximum value at 1. So the question is that information correct? Is that enough information that if you were going to sketch it, you would know exactly what to do? And if not, what could they have done better? So this is a discussion post for you to do on your Schoology page.